Another parallel circuit. This time the numbers are a little bit uglier. One of the resistors is 10, the other one is 20, and the last one is 30. Equivalent resistance. This is going to be a little bit uglier, so I'm going to solve it up here. 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over 10 plus 1 over 20 plus 1 over 30. Full disclosure, I goofed up my math the first time I did this, so I'm going to slow down and make sure I do it right. We need a common denominator between 10, 20, and 30. Common denominator this time is 60. 60, to get the 1 over 10 to match up with 60, we had to multiply it by 6, so the 1 over 10 turns into 6 over 60. The 1 over 20, we got to multiply by 3, so that turns into 3 over 60. And the 1 over 30, we had to double it, so that turns into 2 over 60. That means that my 1 over RT is 6 plus 3 is 9 plus 2 is 11 over 60. So I didn't make up nice numbers this time. What we've just figured out is that 1 over RT is the same as 11 over 60. If 1 over RT is 11 over 60, then we just flip-flop both sides. RT is 60 divided by 11 in ohms. If we want to calculator that, I got that to be approximately 5.45. I'm not doing a very good job with significant digits, but roughly 545 or 5.5, whatever you want to call it. That's the equivalent resistance. If we chop those three resistors off, we could replace it with a 5.45, and the battery wouldn't know any different. Okay, moving on to the next part. If the voltage in the battery is 10 volts, if 10 volts gets put in here, we can work our way around, but if 10 volts gets put in by the battery, if we take the branch on the left, that one resistor has to take out all 10 volts. So if I do V equals I times R, the branch on the far left, the voltage is 10. I don't know the I, but I know that the R is 10 ohms. So V equals I times R, little math, we get a current of 1 amp. That's how much current goes through the 10 ohm resistor. Beside the 10 ohm resistor is a 20 ohm resistor. So if I do the same thing, V equals I times R, that loop, 10 get put in by the battery, and 10 got to get taken out by the 20. So 10 volts get taken out by the 20. I don't know the current, but I know it's got a resistance of 20. A little mental math here. 10 divided by 20 is 1 over 2 is 0.5 amps. In a way, there's a certain logic here. 20 ohms is twice as big as 10 ohms. So if 1 amp goes through 10, since 20 is a bigger resistance, twice as big, only half as much electricity is going to go through it. So in a way, a little bit of logic, more resistance, less amps going through the 20. And then our third resistor, going to squish it way over here. V equals I times R. The same logic, the battery puts in 10, so if we consider the loop that goes through R3, that one resistor has to take out the full 10. I don't know the current, but I know the resistance is 30. Do a little bit of math there. 10 over 30 is the same as 1 over 3. Oops, I drew that wrong. 10 over 30 is the same as 1 over 3, which we could, I'll go 3, again, being a little bit lazy with my significant digits, but 1/3 of an amp. Bigger resistance, even less electricity going through that third one. To finish it off, a throwback to what we were doing before, power equals I times V. If we focus on the 20, the one I happened to draw in the middle, we did the work to figure out that the current through the 20 was 0.5, and the voltage of the 20, because of this cool parallel rule, is 10. The battery put in 10, the 20's got to take out all 10. 0.5 times 10, that means a power of 5 watts.